Hello, me again. Welcome to this presentation on percentage yield. Before we carry on, as per normal, there are some things that I expect you to know before we do this lesson. So you should be pretty comfortable with balancing equations, and you should be able to work out reacting masses in your sleep, essentially. But let's talk about yield. Well, farmers sometimes talk about yield, and they might talk about yield in terms of the amount of crop that they have. Bankers sometimes talk about yield in terms of how much money they've made or how much return, how much yield they've got on an investment. Well, chemists talk about yield, and we talk about yield in terms of how much product have I made, how much stuff have I been able to isolate at the end of my reaction. So in terms of chemical yield, it is the amount of products collected after a chemical reaction has finished. Now we need to talk about theoretical yield here, because we need to use our ideas of moles to work out how much product I should be able to make. That is known as the theoretical yield. Okay, so let's have a look at this example. So we've got calcium reacting with oxygen. I'm going to make calcium oxide, and that's the balanced equation there. Now the question here is, what mass of oxygen is going to react with 60 grams of calcium? Well, let's go through this. So the relative atomic mass of calcium is 40, and therefore 60 grams of calcium is 60 divided by 40, which is 1.5 moles. But according to the balanced symbol equation, I use half the number of moles of O2, notice O2, and therefore I use 0.75 moles of O2. The relative molecular mass of O2, because there are two oxygens in there, is actually 32. And then if we work out the mass of oxygen here, then it's 32 times by 0.75, which equals 24 grams. So 24 grams of oxygen is going to react with calcium. Okay, so using those figures, what mass of calcium oxide am I going to expect to be able to produce? Well, there's two ways of doing this. The first idea is using the idea of conservation of mass. And if I'm using 60 grams of calcium and 24 grams of oxygen, then I should therefore, because I don't lose any mass anywhere, the atoms don't just disappear or appear, we should be able to make 84 grams of calcium oxide according to those figures. But we can also use moles here. So according to the balanced equation, we make the same number of moles here, because I've got a 2 here and a 2 there. I make the same number of moles of calcium oxide as I started off in terms of moles of calcium. And therefore, I'm going to make 1.5 moles of calcium oxide. The relative molecular mass of calcium oxide is 56. And I can use the equation moles times mR to get my mass. So 56 times 1.5 is 84 grams. And unsurprisingly, these figures are the same here. Okay, so is it really that likely that I'm actually going to make 84 grams? Probably not. Okay, chemical reactions rarely have 100% yields. Okay, the reaction might be reversible. The reactants might produce unexpected or byproducts. Some product might be lost in the experiment. You might spill some, you might not be able to scrape it all out of the flask, reactants might not be pure, and the products might be difficult to separate from each other. So we need to think about how we work out our percentage yield. So if I take reactants, and I'm going to make a product. Okay, the top of the flask there is how much I should be able to make. The bottom line there is how much I actually make. And the percentage yield is the amount of product produced in a chemical reaction compared to the theoretical maximum amount of product as a percentage. And there's an equation here. So percentage yield is the amount of product produced divided by the theoretical amount you should be able to produce, times by 100. So if I have 200 grams of limestone and it makes 98 grams of calcium oxide, what's the percentage yield? Well, there's 3 steps that I'm going to take you through here. 1, you work out the MR of the substances you're interested in. 2, you work out the theoretical yield of the product. And 3, you work out the percentage yield using the equation I've just shown you. So let's go through this. Step 1, work out the MR of the ones that you're interested in. Okay, so calcium carbonate has an MR of 100. Calcium oxide has an MR of 56. Step 2, work out the theoretical yield. Well, if 1 mole of calcium carbonate makes 1 mole of calcium oxide according to the balanced symbol equation, well, I've been told in my question that I'm using 200 grams of limestone, which is calcium carbonate, and therefore I've got 2 moles. And therefore I'm going to make 2 moles of calcium oxide. 2 moles of calcium oxide, because of the MR of 56, 2 moles of calcium oxide is 112 grams. Step 3 is work out a percentage yield. I make 98 grams of calcium oxide. I've worked out my theoretical yield, therefore it's 98 divided by 112, and that equals 87.5%. Okay, so it's your turn to try some of these. So using the equation here, I've got some iron oxide reacting with some carbon monoxide, and I'm going to make iron and carbon dioxide. Part A, calculate the mass of iron that can be formed from 100 grams of iron oxide. And that should be part B. What is the yield, the percentage yield of if 55 grams of iron was made? Okay, question 2 then. And again, that should be part B. Using the equation given here, so I've got chlorine reacting with potassium iodide. I'm going to make potassium chloride and iodine. Calculate the mass of potassium chloride that can be formed from 50 grams of chlorine. And what is the percentage yield if 100 grams was made? So pause this video, work it out, and the answers are on the next slide. I said pause! Thank you. So the answers here are 70 grams, 78.6%, 104.9 grams, and 95.3%. Thank you very much for watching this video. Until next time, bye bye.